The face revered for centuries may never have belonged to a corpse at all. It was probably stamped onto linen like ink on parchment. Days after headlines crowed that the Turin Shroud had been vindicated as Christ's burial cloth, forensic modeler Cicero Moraeus fired a digital broadside that threatens to sink the miracle. Working with high-resolution scans and crime scene software, he shows that if fabric truly hugged a human form, its image would flatten into a grotesque smear. The shroud's orderly silhouette, he argues, could arise only from pressing cloth against a shallow carving and peeling it away like a primitive printing plate. Picture wrapping a soaked sheet around your own face. Once laid flat, the nose widens, cheeks drift, eyes separate. Moraeus calls this the Agamemnon mask effect. The Turin image is far too clean for that. To prove it, he ran 2 simulations. First, he draped a virtual skull with a mesh of 30,000 digital threads soaked in hemoglobin-rich serum. When the model cloth was unfolded, the imprint bulged and stretched into an unknowable caricature. Then he repeated the experiment with a bas relief only 6 millimeters deep. This time, the contours stayed crisp. Blood streaks halted exactly where carved ridges ended, and the resulting pattern looked uncannily like the relic's sepia negative. His study, published in an Elsevier forensic journal, dropped into a perfect storm. Just weeks earlier, an Italian textiles lab had reported chemical fingerprints linking the linen fibers to fragments excavated at Masada, hinting at a 1st century origin. Pilgrims rejoiced, documentary crews scrambled, souvenir presses whirred, until Moraeus' models crashed the party and reignited a feud that began in 1354, the year the cloth first appeared in France and was denounced as a fake by the Bishop of Troyes. Radiocarbon tests in 1988 seemed to seal the verdict, dating the sample threads to between 1260 and 1390. Believers counterpunched, claiming the test area had been contaminated by candle soot, patched repairs, and even a 14th century fire that scorched one corner. Every decade since has produced dueling papers, each announcing the end of the controversy. Chemistry could not break the deadlock. Geometry just might. Moraeus treats distortion the way ballistics experts chart a bullet's flight. He measures angular deviation of facial landmarks, computes percentage elongation along warp and weft, and plots those numbers against ratios extracted from ultra-high-resolution shroud photographs. The result is immense. A genuine burial wrap simply cannot yield such tidy proportions. Skeptics remain wary. They point to pollen grains that supposedly trace a road from Jerusalem to Edessa to France, or to faint anatomical nuances they insist no medieval sculptor could predict. Yet, history offers a credible toolkit. 14th century iconographers already traded in contact images. The Veronica veil, the Oviedo sudarium, tinfoil crèche figures dusted with pigment and impressed onto cloth. Whether their aim was devotion or profit, the technology lay ready. And the profit was colossal. Europe in the 1300s reeled from plague and war. A relic displaying Christ's face promised solace, and just as crucially, cash. Innkeepers brimmed, craftsmen flourished, city councils basked in prestige. Chroniclers described bidding wars for miracle working bones, nails, and phials of Mary's milk. In that fevered bazaar, a shroud capable of turning skeptics into believers overnight was as valuable as any fortress. The 21st century has merely updated the business model. Pilgrim caravans are replaced by live-streamed masses, incense-scented chapels by 4K virtual reality tours, souvenir stalls by e-commerce catalogs. Each new research paper swings millions of euros towards or away from Turin. Moraeus' inbox overflowed with both threats and funding offers within hours of publication. Officially, the Vatican takes no side. The Church allows veneration but stops short of dogmatic authentication. Privately, many prelates prefer ambiguity. Debunking could shatter faith. Yet, a declared miracle might become theological quicksand if future data contradicts it. For now, stalemate remains the safest option. Technology, though, refuses to sit still. quantum cascade terahertz imagers, due to enter the conservation arsenal within a decade, promise to map pigment molecules without lifting a thread. They could expose synthetic dyes invisible to older spectrometers or pinpoint microfold fractures that reveal when the cloth was repeatedly folded. A positive scan might rewrite the relic's biography overnight. A refusal to allow testing would freeze the legend in amber, preserving both devotion and doubt. Back in his Brazilian studio, Marias keeps refining code. He's training a neural network to invert the imprint and recover the original source face. One version resembles a Byzantine icon, another a weather-beaten oak effigy, a third a hypothetical 1st century Judean. Each reconstruction peels another layer from the onion, and yet the core refuses to appear. The shroud uncannily absorbs scrutiny and grows only more enigmatic. Perhaps that's its greatest trick. The Turin Shroud's power has never rested on proving itself genuine. Its genius lies in forcing each generation to ask the question anew. By existing exactly at the threshold where certainty falters, it compels science and faith to collide and then slips back into the mist, untouched. Tonight, the linen lies in its climate-controlled vault, glowing beneath tungsten spotlights. Pilgrims will weep. Tourists will still risk forbidden photos. Scholars will still petition for new fibers. And somewhere, a server farm will crunch terabytes of data searching for the day the cloth finally names its maker. Until that dawn arrives, the shroud remains what it has always been, a mirror. Stare long enough, and it reflects not its own origin, but the viewer's hunger for certainty, the eternal human desire to touch the unreachable.
Psst, a giant is hiding in the sky. Kipu is the biggest thing we've ever found in the nearby universe. It's been messing with our understanding of the universe for years, and we've just discovered it. Kipu is dense, powerful, and dangerous to ignore. If we don't understand structures like this, we might be reading the universe completely wrong. So, what exactly is it? It's not a solid object like a planet or a star, and it's not a single thing. It's a superstructure, basically an entire region of the universe, a tangled mess of matter spanning a huge amount of space stitched together by gravity. Kipu is made up of an enormous web of galaxies, galaxy clusters or giant groups of galaxies, gas and dark matter. It's like a superhighway, with galaxy clusters being the cities, filaments being the roads, and dark matter being the invisible infrastructure holding it all together. This giant stretches across 1.3 billion light-years. That means if you traveled at the speed of light, it would still take you 1,003,000,000 years just to cross it. Kipu also holds 200 quadrillion solar masses, even though it only takes up 13% of the observable universe. The name Kipu comes from the Incan system of knotted cords used to record things, called quipus. It was like a writing system. In that system, each knot, color, and twist told a story, numbers, taxes, harvests, and so on. So, when astronomers saw this colossal structure in space, long, tangled, and branching like space cords, they named it after this language of knots. Plus, the shape of the space reminded scientists of those threads. There's a long central filament, and the smaller ones are branching off the sides. What's even more fascinating, Kipu isn't alone. When scientists mapped this part of the universe, they found 5 of these massive structures. They aren't just sitting there either. They formed over billions of years through gravity slowly pulling matter together. All told, all those giants hold nearly half of all the galaxy clusters in that region, 30% of all the galaxies, and a quarter of all the matter in the observable universe. The team that found Kipu used a clever trick. They searched for X-rays coming from galaxy clusters. These clusters aren't just full of galaxies, they're also filled with superhot gas. That gas is so hot it glows in X-ray light, which we can't see with our eyes, but special telescopes can. If there's a lot of that X-ray glow, it means there's a huge amount of matter, galaxies, gas, and dark matter all pulled together by gravity. That's where the densest, most crowded areas of the universe are. So, by following the X-ray glow, the scientists could draw a map showing where the biggest cosmic structures like Kipu were hiding. Why does any of this matter? Because these megastructures mess with everything. First of all, they warp the cosmic microwave background, the ancient light left over from the Big Bang. It's a faint glow of light that fills the entire universe. After the Big Bang happened and our world was created, it emitted its very first light and signals that still haven't completely weakened yet. The leftover radiation is still coming to us, even after 13.8 billion years. By studying this ancient light, scientists can learn what the early universe looked like, and Kipu ruins it for us. These megastructures hold so much gravity that they bend and distort this ancient light as it passes through them. That's called the integrated Sachs-Wolf effect. These warps add noise to the original signal, and now it's harder for us to get a proper, clearer understanding of what the baby universe looked like and how it expanded. They also mess with the Hubble constant. The universe is constantly expanding, and the Hubble constant tells us how fast it's growing. In other words, how quickly galaxies are moving apart from each other. But giant things in space, like Kipu, have so much gravity that they pull nearby galaxies toward them, messing up the way those galaxies move. This makes it harder for scientists to measure the universe's true speed of expansion. They can't tell if a galaxy is moving because of the universe growing or just because it's being pulled by something huge nearby. And finally, there's gravitational lensing. Light in space travels constantly, but it doesn't always follow a straight line. If the space gets distorted, like by gravity, then the light traveling through the space will get bent and distorted too. Gravitational lensing is when light from faraway galaxies gets bent because it passes by something supermassive, like Kipu here. That huge gravity pulls on the light, like how a heavy ball can bend a sheet. And since light delivers information to us, literally makes us see what things look like, this bending distorts how we see galaxies. The images of galaxies end up looking stretched, brighter, or we can even find an entire galaxy in the wrong place. It's like looking at our universe through a warped magnifying glass. If we're not careful, we could misread those distortions and get the wrong idea about what our world looks like. Luckily, we didn't just drop these mysterious superstructures out of nowhere. Astronomers suspected that something like that should be out there. They just didn't know for sure. Our best model for the universe is called Lambda CDM. It says, universe started with the Big Bang, is still expanding, and is mostly made of mysterious stuff, dark energy, and cold dark matter, the CDM part. We can't see or touch these things, but we know they exist, because if they didn't, our universe would literally break apart. This model matches what we do see, like galaxies forming, how stars move, and the overall shape of the universe. So even if some puzzle pieces by themselves are still a mystery, they match the actual picture. And this model actually predicted things like Kipu. When scientists ran simulations using that model, they saw similar structures forming, giant cosmic webs of galaxies tied together by gravity. Kipu matched those predictions in real life. This also means that Lambda CDM is matching real life once again, thank heavens. No huge surprises here. But now that we actually found it, it's the largest known structure in the observable universe. There was another giant before Kipu, the Sloan Great Wall. That one was discovered in 2003 and was believed to be one of the largest structures ever found. And it's still an absolute monster. The Sloan Great Wall stretches over 1 billion light-years across. It's called a wall, but it's not like a wall you'd find on Earth. It's also a vast cosmic web, made up of thousands of galaxies and gas connected by dark matter. What makes both Kipu and the Sloan Great Wall so surprising is that they literally seem too big to exist. According to the Lambda CDM model, structures that huge shouldn't be common, especially at the time they formed. How did these giants form so fast in a universe that's supposed to be growing, expanding, and smoothing over time? And if we keep finding more of them, that would be completely insane. It could mean there's something deeper going on in the way our world is built. It's all part of our crazy Copernican journey, a long series of discoveries where we just keep getting humbled by the universe. Every time we find something like this, we realize even more how we're not the center of everything. First, we learn the Earth wasn't the center of the solar system. Then we found that the solar system is just one speck in a galaxy. Now, even galaxy superclusters, which we believe to be the biggest, are being dwarfed by structures like Kipu and the Sloan Great Wall. But also, these structures won't last forever. Kipu is temporary. Over billions of years, gravity will tear it apart, breaking it into smaller pieces. Some parts will collapse into tighter clusters, others will drift apart. Right now, though, it's one of the most important structures in the known universe. It shapes how galaxies form. It bends light, making it super important for us to decipher. It literally messes with our understanding of the cosmos.
The James Webb Space Telescope, an astounding piece of equipment built to outperform the Hubble Space Telescope, has made a terrifying and amazing discovery that might completely change our perception of the universe. It has successfully detected a faint glow coming from a staggering 7 trillion miles away. Can this glow be shining city lights coming from some mysterious extraterrestrial world galaxies away from us? Well, let's start from the beginning. A few years ago, NASA's infrared Spitzer Space Telescope helped us spot a family of 7 rocky exoplanets orbiting the same star. This star is known as TRAPPIST-1, and recently, our new infrared powerhouse, the James Webb Telescope, has measured the temperature of one of those distant worlds. It was a planet called TRAPPIST-1b. Unfortunately, it turned out that this Earth-like planet was totally uninhabitable. Astronomers took James Webb's mid-infrared camera, called eerie, and looked at the planet's thermal emissions. We can picture the whole process as scientists using heat-sensing Terminator vision. The results were quite disappointing. TRAPPIST-1b turned out to be scorching. Its average temperature was around 450 degrees F. That's as hot as in an oven. Plus, the planet most likely doesn't have any atmosphere. At the same time, this discovery was another record-breaking first for the telescope, which had already produced some newsworthy results by that time. It was the first time researchers detected any form of light emitted by a small and relatively cool exoplanet similar to the rocky planets in our own solar system. No previous telescope had enough sensitivity to measure such dim, mid-infrared light. When 7 TRAPPIST-1 exoplanets were first discovered, the astronomical community was ecstatic. That's because all those faraway worlds were about the size of our home planet and located in their star's habitable zone. It's the region that is just the right distance away from a star for liquid water to exist on a planet's surface. Thus, the planetary system became the best place to look for rocky planets with an atmosphere. But don't get too excited yet. These planets aren't likely to become new worlds for humans to explore, mostly because the TRAPPIST-1 planets are totally out of our reach at the moment. They're just too far away, at a whopping 235 trillion miles away. Their star is also much smaller and redder than our Sun. It's classified as an M-dwarf star. In our home Milky Way galaxy, there are twice as many of such stars as there are stars like the Sun, and they're also twice as likely to have rocky planets orbiting them. It's probably not surprising that astronomers are very interested in such stars. They're the main targets for seeking potentially habitable planets, and it's also way easier and more convenient to observe rocky planets around such smaller stars. But there's a catch. M-dwarfs are more active than our Sun. They frequently flare and spew high-energy rays which are likely to be extremely damaging to planets' atmospheres and any forms of extraterrestrial life. When researchers examined TRAPPIST-1b before, their observations weren't sensitive enough to determine whether this world had an atmosphere, or if it was just a barren rock. But now, we know. The planet is tidally locked to its star, which means that one of its sides always faces the star, while the other is stuck in perpetual darkness. The latest simulations suggest that if this planet had an atmosphere, its temperatures would be much lower since the air would redistribute the heat around both sides of the planet. Unfortunately, the James Webb Telescope recorded much hotter temperatures than needed for such a favorable scenario. It indicates the absence of an atmosphere and knocks the planet off our list of possibly habitable worlds. But the main excitement here isn't actually the features of TRAPPIST-1b. The main takeaway is that James Webb is capable of making such kinds of measurements. It'll help us explore the atmospheres and temperatures of many other distant worlds.
It's been more than a year since the James Webb Telescope, which had taken over 20 years to complete, was launched. And for such a relatively short time, the ultra-modern and most powerful in history piece of equipment has already made plenty of discoveries. By observing the universe at infrared wavelength, James Webb lets us see things no other telescope has ever shown before. The primary goal of this incredible piece of equipment is to study the formation of galaxies and stars that appeared in the early universe. For example, look at the closest to us stellar nursery, a region of space where new stars get born. NASA has shared an image from James Webb that shows a small star-forming region. If you look at the picture attentively, you'll see jets bursting from infant stars. Around them, different colored clouds of cosmic dust are colliding with one another. The view is mesmerizing. The red dust consists of molecular hydrogen. You can also notice that some stars have something like shadows. Those hint at the creation of what will later become planets. At first sight, the image may seem chaotic, but astronomers claim that it's a relatively small and quiet stellar nursery in comparison to some others. Many young stars there are similar in size to our Sun, or a bit smaller. The photo itself was taken with the help of Webb's near-infrared camera, NIRCam. It's the observatory's primary camera that snaps images of the cosmos in 2 different infrared ranges. Another amazing discovery the Webb telescope has made is smoke molecules in a distant galaxy. It's the first time such molecules have been discovered so far away from our planet. The galaxy in question lies 12.3 billion light-years away from Earth. It most likely formed about 1.5 billion years after the Big Bang. Despite such a huge distance between the galaxy and our planet, scientists have managed to detect chemical compounds found in soot or smoke, and it's quite a big deal since it has pushed the record for detecting similar complex molecules back by around 1 billion years. This study has also confirmed the sheer power of the coolest piece of space equipment of all time. It managed to make this discovery despite the fact that the spectrometer needed for the measurements didn't perform to the fullest after having experienced a sudden and surprising degradation. The James Webb Telescope has also helped to boost our understanding of exoplanets. Those are planets orbiting stars other than our own Sun. At the beginning of 2023, the observatory spotted its first exoplanet, LHS 475b. It's located 41 light-years away from Earth and is approximately the same size as our planet. According to NASA, nowadays, James Webb is the only operating telescope capable of categorizing the atmosphere of Earth-sized exoplanets. The research team behind the discovery believes such results underline the precision of the telescope. They hope that it will help us locate many more rocky exoplanets that we might be able to colonize in the future. Even though, at first sight, it may seem that the universe is pretty empty, it's actually a very busy place. And Webb has all the necessary instruments to see all kinds of cosmic events happening out there. Just look at this image of WR-124. It's a star on the cusp of its explosive demise. In the image, the star is about to go supernova. It happens when a star runs out of its fuel and explodes at the end of its life cycle, releasing a giant cloud of space dust and hot gas into space. The star captured by the Webb telescope was at the Wolf-Rayet stage of its life. That's a period when a star is shedding its outer layers before going supernova. The next amazing thing discovered by James Webb is a star-planet hybrid with very strange clouds. This bizarre world, VHS 1256b, is actually a brown dwarf. Those are bigger than planets but too small to classify as stars. They emit some light of their own and are quite hot, but their mass is simply not enough to fuse hydrogen into helium like full-fledged stars do. Space bodies of this kind aren't actually brown. They occur in a wide variety of colors, but those are mostly invisible to the human eye. What we can see is the light they emit, and to us, it appears to be dark orange or magenta. The brown dwarf discovered by the Webb telescope is almost 20 times the size of Jupiter. It orbits 2 red dwarf stars, and to complete one orbit, it needs over 10,000 years. Astronomers first found out about this unusual exoplanet in 2016, but at that time, they didn't classify it as a brown dwarf, and, thus, couldn't explain its puzzling reddish glow. Now, thanks to the James Webb telescope, they know the space object's origin. Anyway, back to those clouds. As you know, clouds on Earth are made of water vapor. But those on the brown dwarf are different. They seem to be made of sand. It looks like good old sand from Earth, but it's actually not. The clouds are made of tiny particles of silicate. Another recent discovery involves several large galaxies that scientists believe were born not long after the Big Bang. They aren't supposed to be there, and no one expected to find them. But the James Webb Space Telescope has spotted them. These galaxies, as massive as our home Milky Way, are full of mature red stars. Astronomers have analyzed the light coming from them and estimated their age 500 to 700 million years after the Big Bang. It means that they came into being when our universe was very young, almost a baby. But the most bizarre thing about these galaxies is their tremendous size and the age of the stars dwelling there. The data received by the telescope don't coincide with the existing ideas about what the universe looked like and how it evolved in its early years. It also doesn't match the earlier observations made by Hubble. And here, James Webb has captured a distant region of space in unprecedented detail. This section of space is known as Pandora's cluster. In the image, you can see 3 massive clusters of galaxies coming together and forming a megacluster. The combined mass of these clusters acts as a powerful gravitational lens. And thanks to this natural magnification effect, scientists can see other galaxies in the region. Astronomers claim that the most recent image of Pandora's cluster is stronger and deeper than they have ever seen. James Webb has also managed to spot thousands of young stars never seen before in the Tarantula Nebula. This space formation got its nickname because of the appearance of dusty filaments spotted in previous images. It's the biggest star-forming region in the local group, which includes the galaxies nearest to the Milky Way. The Webb telescope's images have helped to shed light on the composition of the Tarantula Nebula. The telescope has also detected protostars, infant stars in the process of gaining mass. Astronomers expect that these protostars will eventually form and shape the nebula further. Among other discoveries made by the James Webb telescope, you can see the birth of 50 distant stars. Some of them power protoplanetary disks, which might later form solar systems light years away from our own. Here's one more image from James Webb. You can see a supermassive black hole that has a mass of 9 billion suns. It's so ginormous and ancient that scientists are struggling to explain its existence. Astronomers have also discovered a distant ring of dust, rock, and gas that contains a chemical called methylcation. It's known as a molecular building block of life, and it makes most of the organic material on our planet. James Webb helped researchers see powerful sandstorms on a planet 235 trillion miles away. Astronomers were happy to discover this treasure chest of countless tiny sand particles. Now look at this. Do you recognize this image? Those are the so-called pillars of creation. But this new view shows us just how star-speckled that dusty region actually is. You can compare the new photo with the one taken by Hubble in 2014. This is astonishing proof of scientific progress.
Now, history isn't just carved in stone, but these drawings on 11,000-year-old rocks might be warning us about a freaky future. Both the Mayans and the people at Göbekli Tepe made big predictions about humanity's future. What's eerie is that despite being hundreds of miles and years apart, they used similar symbols. Now, let's get one thing straight. Ancient civilizations often depicted their deities as humanoids. You'll find humanoid representations of celestial beings in ancient Egypt, but also in pre-Columbian societies from the Americas. For example, Aztecs had an important deity they called Quetzalcoatl. He was related to the wind, Venus, and the sun. In some ancient Aztec art, he's depicted carrying a tiny handbag. The shocker is that a very similar winged figure was represented by the Assyrians. Now, it's already odd that they chose similar forms to represent their gods, even though these civilizations didn't have any contact with each other. But to draw an almost identical handbag, that seems like a bit of a stretch. Of course, now, when we say handbags, we mean carvings depicting things that look like modern handbags. Not quite Coach or Prada, but you get the idea. Some theories suggest this mysterious handbag could be related to time travel. We've seen that Göbekli Tepe tells of a great flood that destroyed an ancient civilization. But during that civilization's time, they raised cattle and grew food. They knew how to handle seeds and grow crops. According to one theory, this stylish accessory could have been used for carrying seeds. Since Göbekli Tepe is believed to be near where Noah's Ark might have been found, the people of the area could have gathered seeds to plant in the New World after the Great Flood. Strange? Definitely. But so is everything we've been talking about, so let's roll with it. Another theory on the meaning of the handbag has a much more straightforward approach. In multiple ancient cultures, the circle was used to represent spirituality and non-materiality, but the square was often associated with concepts of the earth and materiality. So, what we modern humans understand as a handbag might be an image that symbolizes the reunification of the earth and sky, of the material and non-material elements of existence. Not a bad theory, I would say. But then, who am I? Some researchers, like Graham Hancock, are not convinced with these previous explanations. For him, Göbekli Tepe is all about little gray people and their contacts with ancient earthling civilizations. You see, right in the middle of this ancient site, there's a special pillar called Pillar 43, or Enclosure D. At first glance, it looks like an astronomical calendar. You see the scorpion? That's the Scorpion constellation. And that ball in the center? It's all about the sun's alignment. We know ancient societies like the Maya or Incas were stellar astronomers. So what's the big deal here? Turns out the folks at Göbekli Tepe were talking about a massive natural disaster that wiped out all forms of life before their time. When astronomers recreated the angles and positions from Pillar 43, it showed an astrological setup from over 13,000 years ago. The stone also depicted a tragic event, a mix of a flood and a meteor shower. The headless man? That's humanity's tragic end. And the snake from the ground? Giant waves washing over the earth. And it's not just one stone telling the tale. Pillar 56 shows more of the Younger Dryas event, or as it's called, the terror from the sky. You see animals fleeing and waves crashing as the meteor shower hits. But wait, while Pillar 43 gives us the exact date of the last disaster, Pillar 18 in Enclosure D gives us the date of the next possible wipeout. The art depicted in this pillar zooms in on the constellation of Aquarius. Now, you might have seen the movie The Age of Aquarius or heard some woo-woo theories about how we're entering this phase right now. You see what I'm driving at? Göbekli Tepe might be giving us the date of the next disaster so that we have time to prep for it. These images could be a survival guide for humanity. Or not. Now, this would be bananas if it weren't for one piece of evidence. Let's check the facts. The Enki comet, discovered in 1786, used to be part of a megacomet, 100 miles wide, made of ice, metal, and rock. It broke up and formed a debris field. Now, instead of one huge comet, we've got millions of smaller ones. When the Earth passed through that debris, the folks at Göbekli Tepe saw a firestorm of comets, all coming from the Aquarius constellation, just like on Pillar 43. Now here's the supposed scary part. We pass through that same debris field every year. If you're watching this in September, October, or November, we're flying through it right now. It could happen that these debris fall onto the surface of the Earth all over again, repeating history. But so far, that's just a theory. The mind-boggling question is, how did the people at Göbekli Tepe know about an event that happened before they were all born? In 2019, excavations kicked off at Turin Tepe, about 40 miles from Göbekli Tepe. But research suggests it might have been settled even earlier. Göbekli Tepe seems to have been a place of worship or an observatory, but Karahan Tepe shows signs of a structured society. Excavations at Karahan Tepe reveal artifacts like intricate carvings, tools, and even possible remnants of buildings. This suggests that these people were not just hunters and gatherers, but had a structured society with spiritual or ceremonial practices. In 2020, researchers started unearthing several other settlements in the area, indicating that Göbekli Tepe was part of a huge metropolis. The whole site is known collectively as Tas Tepler. The thing is, the math around all this has scientists baffled. Around that time, Earth was just leaving its last ice age, and scientists used to think Stone Age civilizations were primitive. But evidence keeps showing up, proving that wasn't the case. For Göbekli Tepe to have existed with that level of tech 12,000 years ago, there must have been an even earlier civilization. That kind of tech doesn't just pop up out of nowhere. And hey, we've got plenty of other proof of advanced societies. Take the Mayans, for example. Recent discoveries have shown they were even more advanced than we previously thought. They built massive cities with roads up to 130 feet wide, painted white to guide travelers at night, a feat you'd expect in places like Portugal or England. These roads, sometimes elevated over swampy ground, formed a network of over 964 settlements, like a giant spider web. A bunch of scientists turned their eyes on this theory, but it could be the connecting point of everything we've been speculating about in this video. After all, the people from the sky could have come down and told the people from Göbekli Tepe about the destruction of a more ancient civilization than theirs. Or not. Remember, don't give up your critical thinking just because you see something on the internet. Anyway, Göbekli Tepe raises suspicions just as Stonehenge and the Great Pyramids of Egypt. When we mix little green aliens into the equation, it explains one way that surreal engineering feats were possible in these sites. But it also underestimates our human ancestors and their thinking abilities. One of the main characteristics of Göbekli Tepe's architecture are the T-shaped pillars. The heaviest of them weigh 20 tons and are around 20 feet. These pillars were erected perfectly, without so much as a dent in them. Sure, that's pretty hard to do without modern machines. But hey, maybe they figured it out and built it after much effort. Now, in case you don't know what I'm talking about, this old pal is supposed to have cracked the secret of the pyramid builders in modern-day America. He used it to build his own castle and other mesmerizing structures. So, hey, I guess we'll have to keep digging to find out the actual facts about it all, huh?
AI can drive a car, design trendy clothes, give you emotional support, and it looks like it can also help us find answers to centuries-long mysteries. Researchers from Yamagata University Institute of Nazca and IBM Japan used a deep learning AI model to find new Nazca lines. Those are distinct white lines on a rusty red background that you can see from a plane while flying over the deserts of southern Peru. Scientists have tried to decipher the meaning of the Nazca lines ever since they were first discovered in the 1920s. There are straight lines, rectangles, triangles, and swirls. There are also some giant drawings. You can see a monkey, a whale, a condor, a hummingbird. The 4 recently discovered geoglyphs, which is the scientific word for those drawings, show a humanoid-like figure holding a club, a fish, a bird, and a pair of legs. What is the hidden symbolism of all that? And why did the Nazca people decide to draw a humanoid in the desert? And did they even know who humanoids were? Let's dig into history to find some answers. The representatives of the ancient Nazca culture created their famous lines more than 2,000 years ago. The geoglyphs have stood the test of time thanks to a dry climate and strong winds in the desert. Scientists found that to form the lines, the Nazca people scraped off the top layer of pebbles, revealing the contrasting soil beneath. The soil's color varies from reddish-brown to yellowish-gray. It makes it look like the lines are constantly changing appearance. It looks like the creators first made small-scale models and then enlarged them to create the full-scale designs we see today. In total, there are more than 800 straight lines, around 300 geometric figures, and 70 animals and plant designs. You can find the first mention of the lines in the 16th century Chronicle of Peru, where they were first described as trail markers in the desert. Since you can't really study the lines and their symbolism from the ground, those geoglyphs only became world famous only in the 1930s. It was the start of the era of commercial planes, so more and more people could witness the lines from their window seats and spread the word. During his research a decade later, Professor Paul Kossak noticed that one of the lines aligned with the setting sun on the day after the winter solstice, which is the shortest day of the year. He supposed that the lines had some astronomical significance. German researcher Maria Reiche, who got the nickname the Lady of the Lines, supported the theory that the geoglyphs served as a calendar and some sort of astronomical purposes. She spent 40 years studying the lines and literally swept them inch by inch. She also moved into a small house close to the lines to protect them from unwanted visitors. And that's how the Nazca Lines mystery was solved. Just kidding. In the 1970s, American researchers began to question astronomical theory. In a region like Nazca, one of the driest places on Earth with only around 20 minutes of rain per year, water is a real treasure. So the straight lines and trapezoids could have something to do with it. They could have been an ancient version of Google Maps, pointing at locations for rituals that the local people organized to get some water and help their crops grow. The images of animals in the Andes region are also related to water. Spiders are thought to be a sign of rain. Hummingbirds symbolize fertility, and monkeys living in the Amazon mean an abundance of water. That could explain the choice of symbols in the desert, but there's no strong proof to support this theory. So the work on explaining the meaning of those mysterious geoglyphs is going on. In the 21st century, the Nazca Lines have become the research ground for archaeologists from Yamagata University. Masato Sakai, a professor of archaeology, together with others on the team, are using high-resolution aerial photography and drones to discover and catalog the lines. They found images of humans, camelids, birds, orca whales, cats, and snakes, most likely created between 100 before current era and 300 current era. Some of the images are around 10 to 20 feet long, and that's why they were pretty tricky to notice. The largest geoglyphs are 1,200 feet across, which is about the height of the Empire State Building. The researchers believe the Nazca Lines were a form of communication in the desert for their creators. The linear ones pointed the direction from valley to valley. The ones drawn on slopes seem to have been drawn along ancient pathways between settlements. Professor Sakai explains that discovering new lines is tricky. Some of them are so poorly preserved that it's hard to spot them in aerial photos. There are also irrigation systems and roads all across the Nazca region, and it complicates the task. And that's where AI comes in handy. The team showed it pictures of previously explored Nazca Lines so it could learn what to look for. Then, AI went through tons of footage taken from planes and satellites and also laser data from previous surveys to identify the lines scientists hadn't found before. The system works 21 times faster than humans, and it made some curious discoveries. Scientists then traveled to the locations it chose to verify the findings. In 2019, AI helped to discover a humanoid-shaped character with a rectangular head who is holding a stick and wearing a headdress. It became a real puzzle for the scientists trying to understand the creature's role in ancient society. The little guy is neighbors with another famous geoglyph. It's a hermit, which is a subgroup of hummingbirds that lives in the forested regions of northern and eastern Peru. The largest of the recently found geoglyphs is a pair of legs. It's more than 250 feet across, about 4/5 as tall as Big Ben. Could be an homage to some ancient supermodel. The fish and the bird are around 4 times smaller. Why they are where they are is still a mystery. Listing new geoglyphs isn't the only way AI is helping scientists. It's doing a lot of good for astronomy. It analyzes vast amounts of astronomical data and uses its algorithms to identify patterns, classify celestial objects, and even predict new events. For example, AI models have been developed to detect and categorize galaxies, search for exoplanets, and identify rare cosmic phenomena. It also helped analyze data obtained by the Kepler mission to discover new Earth-sized planets circling other stars. AI is also transforming the field of chemistry. Machine learning algorithms can predict chemical reactions, discover new compounds, and optimize chemical processes. All of this helps scientists save a lot of time and resources in the labs. If you've ever written a thesis, you know that analyzing vast chunks of information can take forever. Now imagine you need to analyze the archives of the British Library's national newspaper. It's piles and piles of history. So, researchers are teaming up with the curators to develop special software that can analyze the vast amounts of data extracted from these collections. Computational linguists and historians will be able to delve deep into the past and get some insights into changes in society and culture. They'll focus on key periods and track how advancements in technology shaped various aspects of society. AI even helps in the conservation of seals. It's really expensive and challenging to monitor certain species of those cutie pies living in the sea ice zone. Using high-resolution satellites, researchers can now identify the seals in photos, which already helps. But manually counting seals across huge areas of ice is like putting together a jigsaw puzzle of a blue sky consisting of 1 million pieces. It takes a lot of patience, and different analysts come up with different results. Machine learning algorithms can be trained to recognize and distinguish seals in satellite imagery and count them automatically. Researchers can then use this accurate data to monitor seal populations over time and study their behavior and habitat more effectively. Tartesos, a mysterious, highly developed society that once flourished and then, without any warning, suddenly disappeared. Moreover, before they were completely gone, they performed some strange rituals, as if they were trying to save themselves from something. But what happened to these people? Let's try to find out. Let's go to the southwest of Spain, to about 2,500 years ago. Once, there was a beautiful city here, a trade center of Tartesos. Imagine the temple in the middle of a deserted town. A breathtaking, monumental 2-story building. There's a thick smell of frying meat in the air, and the smoke from its frying rises high into the sky, covering the patterns of the sanctuary. The sun has already set, and it's time to prepare for the ritual. We enter the ancient monumental hall. Inside, hundreds of people gather around a long wooden table lined with delicate ceramics and bronze bowls. They feast and drink. These people have much more fun than the animals outside the building. These animals are being prepared for the ritual. Horses, cows, pigs, donkeys, even dogs. All of them were brought here to appease the deities. And what happens after the ritual itself is even crazier. At the end of the ceremony, people take torches and set fire to the whole building. Everything turns to ashes and coals, and when the last embers fade away, they take shovels and begin to bury this place. It will take them at least several days to bury the former sanctuary under piles of earth. They work tirelessly. In some places, the thickness of the layers of mud and clay will reach almost 14 feet. And then, these people, the last known Tartessians, just leave this place and disappear from our world forever. But what just happened? Why did they even do all this? Let's start from the beginning. Tartesos was first mentioned in Greek and Roman texts thousands of years ago. But for a long time, we had no idea what it even was. All the descriptions were contradictory and confusing. Some archaeologists thought that Tartesos was a kind of seaport. Others thought that it was a river or a water reservoir. They even said this place could be connected with the mystical Atlantis. But there was nothing to back it up with, so the scientific community quickly rejected this idea. But today, we know the truth. Tartesos was an ancient civilization. It's been located on the Iberian Peninsula, one of the southernmost islands of Europe. It flourished in the 9th to 5th centuries BC, and then, around 2,500 years ago, suddenly disappeared. They were quite rich. The island had rich reserves of metal, so their economy was thriving. Silver, copper, lead, and other good things were mined in the local Sierra Morena Mountains. Almost all the locals were engaged in trade. For them, it was a common thing.
Isn't that strange that there were so few records left about them? And not so many monuments of their culture have survived to this day. In total, throughout Spain, scientists were able to collect around 20 archaeological finds related to Tartesos. 3 of them were excavated in the Guadiana Valley: Cancho Ruano, Casas del Turin and La Mata. Let's start with the first one. Cancho Ruano was discovered in 1978. This find was one of the most significant pieces of the puzzle. This is one of the most beautifully preserved structures of the Tartessian civilization. Not only the walls have survived to this day, but so did the altar, the moat, and even several artifacts. For example, some jewelry and wine glasses. It was a square building surrounded by a deep moat filled with water. And, to be honest, we still don't know its exact purpose. We only assume that it could be an ancient temple. Some rituals were carried out there. For instance, they would set fire to the temple and cover it with thick layers of sand and clay. They even left some expensive artifacts inside, tools, gold jewelry, and so on. Moving on to the next find. Casas del Turin is one of the best preserved buildings in the entire Western Mediterranean. We only discovered it a couple of years ago, back in 2015. And it hasn't been studied that well yet, but we already know that this place is also pretty weird. Casas del Turin was a very rich building. It wasn't just some kind of temporary camp. It was a place of monumental, impressive architecture. Massive staircases, vaulted ceilings, luxurious materials brought from all over the Mediterranean, and the latest construction technologies. It was supposed to be a place of power, maybe even something like a palace. And yep, it also became the venue for the rituals. It's unclear whether the locals intended to destroy this beautiful place from the very beginning, but this is where they performed the greatest ritual in the area. This ritual involved more than 50 animals, including the most valuable ones, horses. It was their only means of transportation. The fact that these people gave away their horses may indicate that they plan to stay here for some time. Perhaps they hope to appease the deities and settle on local lands. The ritual was carried out exactly as they intended. And just like Cancho Ruano, this place was also set on fire. When the ritual ended, the locals buried this place and left, disappearing into the countryside of the Iberian Peninsula. Now it's an abandoned and quiet place. Just like Cancho Ruano, it's been standing here untouched for more than 2,000 years. The last find is La Mata, which was discovered much earlier than the other two, back in 1930. The resemblance between all of them was striking. La Mata had the same fate. It was burned and forgotten for centuries. All of this is very strange and mysterious. It seems like the locals were fleeing from something. Perhaps something happened that made them start building these banquet halls and arranging large-scale rituals. They thought that their deities turned away from them and tried to appease them. But unfortunately, it didn't work. As a result, they were forced to leave their temples and soon disappeared altogether forever. And by the way, why did they disappear at all? Well, this is another mystery of this civilization. One of the most important questions is, did they know that they were going to disappear? Or was it something unexpected? Did they suffer some kind of sudden catastrophe from which they were trying to escape? Or something else? Scientists have several theories on this. The first theory says that there may have been several major earthquakes and subsequent tsunamis in this region. These natural disasters destroyed local settlements and severely demoralized the survivors. Perhaps they were looking for salvation from this. Another theory is that there were some problems with trading. Since they were rich in metal and lived off their economy, any problems in it could lead to big troubles. If they had some kind of mining crisis, then relations between different nations could worsen greatly, and things could get pretty nasty. The truth probably lies somewhere in the middle. The most current theory says that around the 6th century BC, a large-scale tsunami hit the port. This greatly damaged the economy, which worsened the relationship between Tartesos and its neighbors. In any case, this seems to be speculation. This place is like a dream come true for archaeologists. It stores a huge amount of information and secrets that we have yet to unravel. The Tartessians had no idea that by burying their artifacts, they were making a real gift to the scientists of the future. And while scientists continue to study them, we can check out the stuff they have already discovered. History lovers can see Tartessian tools, horse figurines, and decorated ivory in the Archaeological Museum of Betelgeuse. Let's hope that in the future, scientists will learn more interesting things about this civilization, and we'll finally find out what happened to them.
Now, let's assume that another species, whether humanoid or dolphin-like, could have existed millions of years ago. How do we find their traces? There was a Doctor Who episode about a non-human industrial civilization on Earth that existed long before us. These reptiles, called Silurians, were forced deep underground by a catastrophic rise of temperatures on Earth, and there they thrived for centuries. That inspired scientists to create the so-called Silurian hypothesis. If there was an advanced civilization before us, we should find their traces somewhere. Well, let's try. Climatologist Gavin Schmidt and astrophysicist Adam Frank decided to dive into this themselves. Like us, any technologically advanced civilization would be hungry for energy, so they looked for global effects that would leave a widespread mark. For example, hints of large-scale industrial processes, like plants and factories, and their leftovers. Then comes the question of how long these civilizations would last. If they existed for a long time, we should look for long-lasting signs, like residues from burning fossil fuels, mass extinctions, synthetic chemicals not found in nature, and even traces of nuclear fission. Basically, we should search for the same kinds of things that humans are currently leaving behind as evidence of our activities. Unfortunately, this evidence isn't that easy to find. Let's imagine an unsettling scenario if humanity suddenly disappeared. Even though it seems like we've left a lot of changes on our planet, the future civilization millions of years from now would struggle to find any remnants of our existence. Why? Well, our planet has existed for 4.5 billion years. Complex life on Earth has existed for more than 400 million years. Compared to that, our industrial period only lasted around 300 years, and we haven't left any significant traces. Our record of Earth's history is full of gaps, especially the further back you look. The fossil record captures only some things, being very selective and incomplete. On average, one fossil emerges every 10,000 years, and dinosaur footprints are even rarer. Mountains rise, oceans change, and plate tectonics can easily wipe out evidence of entire civilizations. After a couple of million years, chances are any physical signs of a civilization would disappear. In order to find at least something, we have to look for things like odd sediment patterns or unusual isotopic ratios. Also, fossils mostly form in water, leaving us in the dark about creatures on land or in the jungles. So even if there was a technologically advanced society millions of years in the past, and even if they were far more advanced than us, we might struggle to find any clues of its existence. Frank and Schmidt try to understand how we could ever hope to spot signs of them. Discovering actual cities would be the ultimate proof of a Silurian-style civilization on Earth. But Adam Frank isn't too optimistic. Even now, our cities cover less than 3% of the surface, making it easy to miss ancient city ruins. Whether a city survives over tens of millions of years depends on whether the land around it is sinking, getting locked into a rock, or rising, getting worn away by rain and wind. So places like the French Quarter in New Orleans might have a better shot of making it into the geologic record than, say, Haight-Ashbury in San Francisco. When it comes to finding artifacts, the odds are pretty slim as well. No prehistoric iPhone would survive millions of years, fancy glass or not. Finding their fossilized remnants might be a bit more promising, but it's still tricky. Considering modern humans have only been around for about 100,000 years, it's quite possible that we might overlook any traces of an earlier advanced species. There is one thing, though. We could stumble upon their traces in rocks. Our current chaotic era might leave a distinct mark on the Earth's geological history, especially since we're basically experiencing PTM 2.0. I'll get to that in a moment. So they try to look at the changes in the carbon cycle. Humans have been releasing a lot of fossil carbon since the 18th century. This leaves a special mark in the carbon isotope ratio, like a signature that shows the difference between carbon in living things, such as seashells, and carbon in lifeless volcanic rock. Scientists also look for signs in the way sediments are arranged. Large coastal deltas might mean that there were bigger rivers made by folks in this hypothetical civilization. Traces of nitrogen could suggest big-scale farming, where they used a lot of fertilizer. Spikes in metal levels in the sediment could mean runoff from heavy industries. Of course, a single find like that wouldn't tell us anything. Schmidt says the key is to look for multiple signs together. Without clear artifacts, the uniqueness of an event might show in various clues rather than a set of changes linked to a single cause. On a quest for Silurian-style clues, scientists even decided to check the Moon. Some astronomers find it surprising that no one has looked into this before. They even joked about the possibility of dinosaurs building rockets and leaving traces on the Moon or other celestial bodies. These astronomers think that Earth-like planets tend to erase signs of civilizations on their surfaces. So they're exploring the wild notion that these beings might have been space travelers. In that case, remnants of their technology, known as technosignatures, could be lurking not only on our Moon, but also on asteroids, or even buried on Mars. There they might endure for millions or even billions of years. Unfortunately, so far, despite digging into the past 380 million years and examining all suspicious events, the researchers haven't found a clear match for a technological civilization. They don't give up, though. Frank calls for more investigation. For example, we could study how modern industrial chemicals stick around in ocean sediments. This, he believes, could help us identify similar chemical traces in the Earth's history. If there are no traces, why do we even bother to find something like that? This research is based on Schmidt and Frank's recent papers. They were delving into the Anthropocene. It's the proposed epoch dominated by human activities on Earth. It's full of these things called hyperthermals. They're prehistoric events when temperatures on Earth sharply increased over a relatively short time. They're like extreme heat waves from the past. A great example of this is the Paleocene-Eocene thermal maximum, or PETM for short. It happened around 55.5 million years ago and saw a rapid rise in global temperatures. Over 200,000 years, the average temperature on Earth jumped from about 9 to 14 degrees Fahrenheit. We study these hyperthermals to understand how they occurred, from natural causes or human activities. So, these hyperthermals sparked the genesis of Frank and Schmidt's research. To study them, scientists started examining chemical signals and tracers left in rocks. When doing that, Schmidt and Frank uncovered some eerie parallels between all the climate issues we have today and past periods of rapid temperature shifts. There's a close similarity between the PETM and other hyperthermal events. So all this work isn't just about solving a historical mystery. Understanding our impact on the environment can guide us to finding better ways to live in harmony with the planet and avoid becoming a forgotten species in the future. Our Milky Way is filled with lots of planets that could be just right for life, but we don't know if there are other civilizations out there. Earth is the only place we know of with living beings. About 200 years ago, people wondered if there might be civilizations on Mars. Back then, it was a real question. But once we got pictures from space probes, we decided there wasn't any evidence for it, and that idea got stuck in our minds. Now, it's not even considered a valid topic for serious science. It's seen as kind of silly. But no one has set clear limits on what could have happened on our own planet a really long time ago. So, even if there is no proof, we shouldn't throw away the possibility. Don't forget, it took humanity a while to recognize dinosaurs. Maybe Silurians are just patiently waiting for their time.
For decades now, scientists have been discovering new planets outside our solar system. By 2023, we've found more than 5,000 of them, and many of these exoplanets could potentially even have life. Now, if you're ready for a wild ride through space, let's find out what potentially habitable planets we've discovered in the last few years. LP890-9b and LP890-9c. Buckle up because we're heading to LP890-9, a red dwarf star located a whopping 105 light-years away from Earth. This star is quite cool compared to our Sun, in terms of temperature, of course. It has a temperature of about 4,700 degrees Fahrenheit. Now, this little guy may be small, but it's packed with surprises. For example, 2 exoplanets orbiting around it. Moreover, both of these planets are likely terrestrial, meaning they are rocky, just like Earth. First up, we have LP90-9b, which was discovered in 2022 using the TESS telescope and later confirmed by the Betelgeuse telescope. This planet is a super-Earth, weighing in at about 13 times the mass of our own planet. It's also slightly bigger than Earth, with a radius about 1.3 times larger. And if you thought Mercury's orbit around the Sun was quick, just wait until you hear about LP890-9b. It takes about 3 days to complete one lap around its star. Imagine falling asleep in freezing winter and waking up in hot summer. But the real showstopper here is LP890-9c. This one was discovered by the Betelgeuse telescope. It's a bit further out from the star and takes a leisurely 2.5 times longer to orbit than LP890-9b. It's also a bit larger than Earth. But its real claim to fame is its location within the habitable zone of its star. That means it could potentially have liquid water on its surface and a climate suitable for life. Now, this planet becomes a prime candidate for studying its atmosphere using the James Webb Space Telescope. But hold on. It's not all sunshine and rainbows for LP890-9c. It's also really close to its star, meaning it's full of radiation that could potentially make it less habitable. And to top it off, it's tidally locked, just like our moon. That means one side of the planet is always facing the star and is incredibly hot, while the other is always in the dark and really cold. Scientific models suggest that this planet could be more like Venus in terms of its atmosphere and climate. And Venus isn't known for being human-friendly. But despite these challenges, LP890-9c is still a fascinating exoplanet worth studying further. Who knows what secrets it may hold? Let's move on to the next candidates. GJ1002b and GJ1002c. An international team of scientists, led by researchers at the Instituto de Astrofísica de Canarias, has found 2 Earth-like planets just 16 light-years away from our solar system. They both orbit a red dwarf star called GJ1002. Our Sun is a yellow dwarf, which means that GJ1002 is much cooler and fainter than our own Sun. But that's okay. Both planets are very close to its star, so it shouldn't be too cold or dark on them. These planets, called GJ1002b and GJ1002c, are both in the habitability zone of their star, meaning they could potentially support life. Also, both of them have masses similar to that of Earth. GJ1002b is the inner planet and takes about 10 days to orbit its star, while GJ1002c takes a little over 21 days. These planets are great candidates for studying their atmospheres and could even be targets for future missions to search for signs of life. The most important thing is that these 2 planets could potentially support life, and that's pretty cool. Plus, the fact that they're located so close to us means that we might be able to visit them someday. Well, maybe not us personally, but And maybe one day, we'll even find some extraterrestrial life on one of these planets. Now that would be out of this world. But moving on to the next one. Kepler 1649c. Kepler 1649c, also known as the Lost Exoplanet, was rediscovered in 2022 by scientists using data from NASA's Kepler spacecraft. This exoplanet is located about 300 light-years away from Earth and orbits a small, cool star called Kepler 1649. It's about the same size as Earth, and just like the previous ones, it's located in the habitable zone of its star. Initially, the data about this planet was discarded. A special computer program called RoboVetter, written to automatically sift through the volumes of Kepler data, labeled this candidate as a false positive. In other words, the program thought it was just some kind of an error or interference. Fortunately, the researchers double-checked such things, and when rechecking the data, they managed to rescue poor Kepler 1649c. Now we know that this is a terrestrial planet just like Earth, and if it really does contain water, there could even be life there. But don't pack your bags just yet. There are still many unknowns about Kepler 1649c. For example, we don't know what its atmosphere is like or what kind of surface it has. It's also possible that the planet is tidally locked, just like LP 890-9c. That would be, unpleasant. That's why Kepler 1649c is definitely worth further study. Maybe it turns out to be a perfect place for us to set up a vacation home in the future. Just make sure to bring plenty of sunscreen since the planet is pretty close to its star and things could get pretty toasty. Kepler 1638b. This exoplanet is located about 5,000 light-years from Earth in the constellation Cygnus. It's also located in the habitable zone of its star. It was discovered in 2020 by the Kepler spacecraft through the process called transiting. They basically take a bunch of photos of the star at different times. After that, the programs analyze these photos and look for small spots and dots on them. These tiny dips in brightness may mean that a planet was passing by the star. Kepler 1638b is a bit of an oddball compared to most exoplanets we've found so far. It's about 4 times the mass of Earth and has a radius about 2 times that of Earth, making it a super-Earth exoplanet. Its orbital period is about 260 days, which is quite close to our Earth, and that's great. Finally, at least somewhere, winter and summer will flow normally. Kepler 1638b could have some liquid water there. That's why it's also a good candidate for further study, to see if it could potentially support life. Let's hope that we'll find out more about this planet in the future. And finally, the last one. Kepler 438b. Kepler 438b is an exoplanet located approximately 640 light-years away from Earth in the constellation Lyra. It was discovered in 2015 by the Kepler Space Telescope. One of the most interesting things about Kepler 438b is its size and location. It's about the same size as Earth and also orbits within the habitable zone of its star. But there are a few catches. For one, Kepler 438b orbits around a red dwarf star, which are known for their high levels of solar radiation and flare-ups. This could make the surface of the planet too hostile for life as we know it. In addition, Kepler 438b has a much shorter year, only around 35 Earth days long. This could lead to extreme temperature fluctuations on the planet's surface, but maybe it's home to some hardy extraterrestrial life forms that have adapted to its unique conditions. Or maybe not. Either way, it's definitely worth keeping an eye on. This is a small list of exoplanets that we've discovered in recent years. Now, with the use of new technologies, we'll be able to find new exoplanets much more often. Let's hope that at least a few of them will really be inhabited. Have you ever wondered how the world will go down in flames? Will it be due to zombies, extraterrestrial civilizations, or AI taking over? Nah, turns out it might actually be mosquitoes and scientists causing the chaos. It's funny how things created by nature aren't as threatening as the stuff that doesn't exist naturally. And you know what's on that list? Editing the DNA genome. Experiments with the genetic structure of living organisms can produce completely new species, and no one knows how nature will react to them. Let's look at an example of gene drive. So it all started with malaria mosquitoes. To somehow stop the growth of their population and prevent the spread of malaria, scientists created a gene that magically made mosquitoes only have male offspring. Several insects with this gene transmitted it to others during the mating season and thus spread infertility. Scientists were able to stop malaria and destroy almost the entire mosquito population. But imagine if something went wrong in the mosquito genome and their population began to increase exponentially. Malaria could spread across all continents and create huge problems for all of us. Now, let's move from the little mosquito problem to a planetary disaster that can be caused by the desire for knowledge, which is deeply embedded in our nature. British cosmologist Martin Rees once said that we lived in the 1st century when human beings could determine the planet's future. It seems that it's so easy not to destroy yourself, but our nature is quite complicated. In pursuit of solving the mysteries of the universe, we have built a giant machine that, according to some people, may destroy our planet. And this device is the Large Hadron Collider. The main task of this giant machine is to accelerate particles and make them collide with one another. Scientists expect that the collider will help better understand the structure of our universe. In simple words, this is a miniature simulator of the universe. Using it may also shed light on the mystery of dark matter. During operation, the machine compresses atoms and makes them crash into one another at great speed. Perhaps this is how our universe appeared. Some people fear that a small black hole may form because of this collision. A tiny particle with a huge weight will pull all objects inside itself. Its mass will grow, but its size won't change much. As a result, it will compress the entire Earth and turn it into a ball measuring a little more than 300 feet across. At the same time, our planet will still have the same weight. A powerful gravitational pull on such a small area of matter can form a black hole that might later swallow up our entire solar system. There are also theories that the Hadron Collider could open a portal to a parallel universe with creepy monsters that would enter our world. But of course, such theories have little to do with science. Scientists have already launched the collider several times, and as you can see, nothing terrible has happened. But there is a small nuance. With each launch, scientists increase the speed of particles. Who knows what will happen when they accelerate them too much? According to Martin Rees, the probability that Earth will become a black hole is very, very small. Particles with a much larger energy charge fly in space faster than in the Hadron Collider, and nothing catastrophic happens. Okay, now let's go back to our genomic games to see what else can happen if we continue experimenting with nature. The main problem might be an imbalance in ecosystems. In the 19th century, sailors accidentally brought mice to Gough Island in the South Atlantic Ocean. Rodents had no dangerous enemies there, so their population began to grow. Mice began to displace dozens of birds from their home. The rodents attacked the chicks and reduced the population of entire species. Trying to save the birds, scientists decided to get rid of the mice, but these little creatures still managed to survive. As a result, the balance of the whole ecosystem was disrupted. Using gene drive to get rid of one species can lead to uncontrolled population growth of another. Imagine that malaria mosquitoes controlled the population of some flies. And what would happen if these flies lost their main natural enemy? The population of these flies would start destroying other species, and it would begin a chain of destructive events. All this suggests that playing with things that don't exist in nature is very dangerous. We worry a lot about how artificial intelligence can take over the world and eliminate us. Still, at the same time, we don't pay attention to our actions. Genome editing can lead to positive consequences, such as the appearance of healthier people, and destructive ones, like the creation of artificial bacteria that can cause serious health problems. In general, destroying other species is a trait inherent in humans. Because of our actions, many animals have disappeared from the face of the earth. Moreover, we even destroy each other. Such aggressive behavior is our nature. And artificial intelligence doesn't have anthropomorphic properties. Its logic may be completely different from ours, and instead of destroying people, it might strive to save them. And we have something to save us from. Remember the giant asteroid that erased more than half of the living creatures on Earth? The fall of the space rock caused a massive blast wave, a tsunami, earthquakes, and dust clouds that covered the sun. Dinosaurs and other animals couldn't survive in such conditions. But what if something similar happens these days? Fortunately, we're better prepared than dinosaurs. Firstly, we have the technology to track giant meteorites and calculate their trajectory. And artificial intelligence can also help us with this. Secondly, we can destroy an asteroid before it reaches us. Several powerful rockets will quickly deal with any space rock and turn it into cosmic dust. Moreover, we will know in advance about its approach. But suppose that a huge stone the size of dozens of Everests will fly towards us. In that case, humanity should hurry with Mars colonization. But don't worry. Observing the sky shows that large asteroids capable of causing severe damage to our planet are moving in a different direction. The most giant known asteroid that could collide with Earth might do so in 2088. The probability that it will fall on our planet is 1 in 50,000, so you shouldn't have to worry about threats from outer space. What lies in the bowels of our planet is much more dangerous. Millions of tons of magma and hot gases can burst to the surface through destructive volcanic eruptions. More than 70,000 years ago, a large-scale eruption threw a tremendous amount of ash into the air, which then floated in the atmosphere in the form of a giant gray cloud for a long time. As a result, Earth's surface cooled down by several degrees, which led to one of the most massive extinctions in the history of our planet. Some eruptions happen not only inside volcanoes. There's such a thing as flood basalt. A colossal magma bubble accumulates under a vast area and begins to seep through faults in different parts. Magma slowly goes out there for many years and destroys all living things around. And the worst thing about this situation is that we can't do anything about it. Humanity has learned to track meteorites in space, but we're still not good at predicting a volcano's behavior. Even if we find out that some giant rock will wake up in the next 6 months, there's nothing we can do about that. We won't be able to prevent an eruption. All we can do is evacuate people from dangerous territory. We have no protection against earthquakes, and even more so, we can't stop the emission of ash into the atmosphere. It's possible that artificial intelligence will help us with this in the future, but right now, we're powerless. As you can see, there are several options for the end of the world for humanity, and they're all slightly different from those imposed by pop culture and the media. In the end, is it right to look for threats from space or artificial intelligence?
The only life that we are certain about so far in the entire universe is on planet Earth. Whether that life is intelligent is, let's say, arguable. But anyway, it's not surprising that we're tirelessly searching for life on other planets. So far, they've discovered more than 4,000 of them. But what's even cooler? NASA has compiled a new list of 24 planets that aren't just Earth-like, they're better. The conditions on them are so good that they're more comfortable than on our planet. So let's examine some of them. KOI 5715.01. Let's be coy, shall we? This wonderful planet is in the constellation Cygnus. And why is it so wonderful? Well, our sun is a yellow dwarf. And sorry, son, even though you're not bad at supporting life, there are some stars that can do it better. Nothing personal. The planet KOI 5715.01 orbits near an orange dwarf. Orange dwarfs are stars slightly smaller than our sun and have a little lower luminosity. Did you like the alliteration there? Anyway, don't worry, it doesn't mean we're going to live in complete darkness. In fact, if the planet is found closer to the sun and it has a thicker atmosphere, it may even be lighter and more colorful than on Earth. Now, our sun has a very short lifespan. Right now, it has 7 to 8 billion years left to live, a little longer than Earth's age. But orange dwarfs can live from 45 to 70 billion years. This is great not only because we'll be able to hang out on this planet longer, but also because the planets around these stars have more time to form life. Now, ideally, we would need to find a planet next to an orange dwarf that is about 7 billion years old. It's very likely there will be at least some organisms there. KOI 5715.01 is about 5.5 billion years old. Yeah, it may not seem mature enough, but that's okay, neither do I. Our Earth is a billion years younger, and that didn't stop us. The planet is quite close to its star and is in a habitable zone. 1 year there lasts 190 days. Imagine going to elementary school and already getting a driver's license. It's almost 2 times larger than the Earth. The average temperature there is 52 degrees Fahrenheit, which is slightly less than ours, 57. But it mostly feels warmer there because strong gravity helps it hold on to heat in the atmosphere longer. It's a little too far away though, like 3,000 light-years from Earth, which is about 18 quadrillion miles. Yep, better bring a really big lunch with you. KOI 3010.01. This planet is found next to the star KOI 2010. This planet sounds like a very pleasant world. The average temperature on this planet is 67 degrees, so a little warmer than ours. But that's a good thing. Scientists believe that on a perfect planet, the temperature should be just about 10 degrees hotter than on Earth. The more heat there is on the planet, the more comfortable it is to live there. Also, the higher chances of developing life. The radius of this planet is nearly 1.5 times larger than Earth. There's some atmosphere, although we're not yet sure about its composition, but it's probably like the Earth's. Scientists think that we'll find an ocean there, and it can cover up to 60% of the surface, which is also cool. In a perfect world, water and land should be distributed more evenly than on our planet. A little more land means a little more territory and resources, right? But listen, this planet is actually very similar to the Earth. The semblance is so striking that scientists believe we have an 84% chance to find life there. Of course, not necessarily an intelligent life, but at least some animals. Wouldn't that be cool? Now, what do you think they could look like? Very Earth-like planet, but with stronger gravity. Well, if someone lives there, they're probably big but have a small height and strong little legs. Sounds adorable and scary. But we won't be able to find out the truth anytime soon. So far, for us, these planets are microscopic dots in space. We only have some dry, boring data about them and don't even know what they look like. We'll have to wait until we can find a way to get closer to these planets. Kepler 186f. This is also one of the best candidates for having life. This rather cute planet was nicknamed the Earth's cousin because it does have a strong resemblance. Anyway, these two planets are like sisters, not twins. Kepler 186f rotates near a red dwarf. Red dwarfs are stars even dimmer and smaller than orange dwarfs. Yeah, they'll also live for a very, very long time, but their luminosity is also quite low. However, Kepler 186f is closer to its star than we're to our Sun, so it shouldn't be too dark there. Well, at least not night-like dark. The sky on this planet is sure to be an unusual shade of red, like sunsets on Earth. What do you think? Would you like to live on a planet with an eternal sunset? The size of this planet is about the same as Earth. Not bad, not perfect. Why so? Because the coolest planets are those that are bigger than Earth and have stronger gravity. Now you'll probably say, but wouldn't it be harder to walk there and even harder to get out of bed on Monday? Of course. But on the other hand, this planet will pull the atmosphere better. The atmosphere will be thicker and denser. This means more protection from the scary space stuff, more oxygen, and more heat. Not to mention the fact that the bigger planets have more space to settle. Awesome, right? But of course, the Earth's size is also an excellent choice. Another cool fact is that the tilt of Kepler 186f is about the same as ours. It means that there should be stable seasons and a normal day-night cycle. Do you know how important the tilt of the planet is? Let's look at Mars. Mars is also, in fact, found in the habitable zone of our Sun. But its tilt is very unstable, and as a result, the entire ocean that could have been on it once now completely dried up. Today, it's just a red desert, and there's no life there. At least not as far as we know, but you see how important these tiny details are? This planet is also quite far away from us, 490 light-years. That's about 3 quadrillion miles. So yeah, we're just going to keep waiting for intergalactic travel. Kepler 62e and 62f. These planets were called the most Earth-like before we discovered Kepler 186f. They're very comparable to our home. Kepler 62e is about 1.5 times larger than Earth, and Kepler 62f is just slightly smaller than that. They're located in the constellation Lyra, which is about 1,200 light-years away from us. They both also orbit a red dwarf. 1 year on Kepler 62e lasts about 122 days, even less than on that first planet we talked about. Scientists believe that both 62e and 62f are sort of water worlds, warm places mostly, or even completely covered with water. If there is land there, it's probably just some islands. A world consisting entirely of islands. A fantasy dream for some, think Hawaii, and a nightmare for others, think Megalodon. But if you're a fan of ancient marine animals, just imagine how gigantic they could be there. Still, there are many things we don't know about this planet. Does it have a surface? What about its composition, density? One day, maybe we'll be able to answer these questions. And so, that's it for the super-Earths. Of course, the original list is much longer, and you can go check it out on the internet. Now, the best thing about all this is that these are planets that are better than the Earth. But we also know thousands of other exoplanets that are just close enough to ours. And the odds are, a few of them have at least some form of life. But they're very, very far away, so we have no way to check it out right now. Perhaps, down the road, we'll find some cool creatures on many of them. The planet races through space. Its orbit is unstable, like a pool ball gliding across the table looking for a target to collide into. Only this ball is the size of Mars, and it's going 9,000 miles per hour. Boom! It crashes into another planet. This Mars-sized object was called Theia, and what it smashed into was Earth. The impact released 100 million times more energy than the asteroid that wiped out the dinosaurs. The planetary collision threw tons of solid material from both objects out into space. But only one of the bodies survived. Theia was obliterated and then swallowed entirely by early Earth. But that debris didn't go flying endlessly into the cosmic void. No, something crucial happened. All those solid chunks gathered into a cloud. Gravity squished it together, pressing more and more. And in the end, our moon was born. So goes the theory. At the time of the impact, the solar system was just forming, and this rendezvous of epic proportions probably wouldn't have happened if it weren't for a newly formed Jupiter throwing Theia off its orbit and straight into Earth. Our young planet withstood the blow. Time passed. Earth evolved. Its surface will become unrecognizable over the next 4.5 billion years. It's hard for the human mind to understand this vast amount of time, so we'll squeeze it all into one day. If midnight is when Earth first formed from gas and dust that remained after the Sun's creation, the next 4 hours show a lifeless planet. Red hot, covered in lava, constantly bombarded by asteroids and, as you know by now, even a whole other planet. Yet life finds a way. The first cells appear. It's 4 a.m. on the clock. At 2:08 p.m., we see the first single-celled organisms form. It's not until 8:28 p.m. that sea plants appear. 20 minutes later, what's this? Jellyfish. After them, the planet flourishes with different fish, reptiles, insects. The forests grow at 10:30 p.m. Between 10:56 and 11:40, dinosaurs roamed the Earth. The giant lizards ruled our planet for less than 1 hour. A minute before the dinosaurs' extinction at 11:39 p.m., the first mammals begin to run around the planet. At 11:58 and 43 seconds, humans appear. In the cosmic scale of things, we've only ruled this planet for 1 minute and 17 seconds. So here's the main question baffling scientists. Why didn't life on Earth ever stop? It had every chance to cease. Why didn't our planet become like Venus or Mars? They both once had an atmosphere and oceans. Today, they're lifeless deserts. Forget about complex scientific concepts and theories of the universe's structure. Our little rock and all its inhabitants are just incredibly lucky. Professor Toby Tyrrell at the University of Southampton used computer programs and climate simulations to solve the puzzle of why asteroid collisions and ice ages didn't turn our little rock into a lifeless wasteland. The research team took not 10, 100, or 1,000 virtual planets similar to Earth. They used 100,000 for the experiment, and every single one of those 100,000 were simulated 100 times. They exposed these virtual planets to different phenomena. They were bombarded by asteroids, frozen, exposed to epic eruptions of supervolcanoes that blacken the skies and block the surface from the sun's rays. Just 9%, or 8,700 of them, were successful one time in 100 simulations. Of that group, 4,500 planets remain inhabited 10 times. Only on one planet out of 100,000, life didn't stop all 100 times. If life is a lottery, Earth got extremely lucky. In 2009, the unique Kepler telescope was launched into space. Its task? Search one patch of the night sky, or 150,000 stars, for rocky Earth-like planets. Over 9 years in service, it ended up surveying more than 500,000 stars. In all that time, with all those observations over nearly a decade, Kepler discovered 2,600 possible Earth-like planets. The weird thing is, most of them are a type you can't find in our own solar system. They're something between the size of Earth and Neptune. But back to the real Earth. If you go far from the city and look up at the sky, you'll see an ocean of stars. If you're lucky and it's a clear night, with an unaided eye, you could count a maximum of 2,500 points of light. Yet, there are at least 100 billion stars in the Milky Way. Some estimates put the numbers of stars in the Milky Way up to 400 billion. So, where's this giant range coming from? Well, counting stars isn't exactly an easy job. Scientists obviously don't number each one individually, 1, 2, 3, and so on. You know how long it takes to count just 1 billion? Over 100 years. Now, multiply that by 400. Instead, they look at small patches of space and use some complex scientific formulas to make educated guesses of how many stars there are in total. You can do a similar experiment yourself. Imagine a bucket filled with 10 pounds of rock, sand, soil, and other items. Your job? Understand how many rocks are in that mix. We'll count only those rocks that are visible to us from above. Get a rough estimate of their volume and weight, what percentage of the total we can see, and with some calculation, you can get a number. Is it exact? Nah. Why? Because you can't know if the rocks in the bucket are spread evenly throughout, or if they're all about the same size throughout. What if the ones at the bottom, if there are any, are bigger or smaller than your sample view? They could have completely different weights and volumes. That bucket is our Milky Way galaxy, and the rocks you are counting are stars. The point? Scientists can't know for sure how many stars there really are. Maybe 100 billion, or perhaps 4 times that. Of those, 4 billion are like our Sun. With our own galaxy, the most accepted estimate for planets that could potentially support life is 300 million. Though, as the tradition of scientific inexactness goes, that number could be up to 5 billion or more. Either way, lots of real estate to choose from. And that's just the Milky Way. But get this, it's just one of 200 billion galaxies in the observable universe. The most recent research puts that number 10 times higher, something like trillions of galaxies in space. And we've only studied less than 10% of them. As for how many stars there are in the universe, scientists put it at 1 septillion. That's 1 followed by 24 zeros. Again, it's all estimates because we can't know for sure. So far, one thing is clear. Our Earth is the only place in the universe that we know of where there's life. And this planet has done everything it can to change that. Over the past 540 million years, more than 20 major extinction events have occurred. The last one was 66 million years ago. Yep, it was the one that took out the dinosaurs, and 75% of all life on this planet, for that matter. An object 7 miles across in diameter smashed into our planet. It was going 120 times faster than the fastest car today. Over 900,000 miles all around the impact site, everything caught fire. A huge tsunami swept across the world's oceans. Billions of tons of dust and sulfur rose into the sky and blocked the sun's warm rays. A global cooling came to Earth. A little over 200 million years ago, there was a lesser-known extinction event that wiped out half of all life on the planet. Most likely volcanoes or an asteroid strike are to blame. Other theories say the movement of tectonic plates triggered another ice age. At that time, huge crocodiles ruled the Earth. They disappeared, and new animals entered the arena of history – dinosaurs. But the worst this planet has ever seen was the Permian-Triassic event about 250 million years ago. 80% of marine life, 70% of land animals and plants, all gone. Volcanoes spewed out a colossal amount of lava where modern-day Siberia is, but it affected the entire planet. Around 445 million years ago, the dominant life form on our planet was marine invertebrates. There was only one continent, Gondwana, and plants were just starting to flourish on land. But something happened that took out 75 to 85% of all living organisms. It could have been an ice age, rising temperatures, or a more daring theory. Some think it could have been a huge star exploding 6,000 light-years from Earth. It launched a jet-like gamma-ray burst that ripped across space, and poor little Earth happened to be in its path. It burned off the ozone layer instantly. Yeah, we kinda need that thing to protect us. Case in point, no matter how much this planet, or even the universe, tries to wipe out life on Earth, which is here in the first place from unbelievable odds, life always finds a way.
Imagine you're looking up at the sky on a clear night, and you see all those beautiful stars twinkling up there. Well, one of them is Betelgeuse, a celebrity among stars. If you want to catch a glimpse of it, look up at the Orion constellation. It low-key looks like an archer holding a bow, and you can spot Betelgeuse as the reddish-orange dot on their shoulder. It's one of the brightest stars in the sky, so it's hard to miss. Betelgeuse is not your ordinary star. First of all, it's gigantic, up to 1,000 times the size of our Sun. Can you imagine that? It's so enormous that if we could somehow replace our Sun with Betelgeuse, it would engulf all the inner planets, including Earth. And here's another fun fact. When we look at Betelgeuse, we're actually looking back in time. Yep, you heard it right. Betelgeuse is about 600 light-years away from us, so the light we see today actually left the star 600 years ago. It has quite a history. This star has been shining brightly for millions of years. Long, long ago, even before smartphones and telescopes, ancient Sumerians were the first to spot Betelgeuse in the sky, and it's been a diva this entire time. For example, in 1866, Betelgeuse became one of the brightest stars in the night sky. It was so dazzling that people could see it even during the day. Astronomers all around the world went bananas documenting this extraordinary event. Since then, Betelgeuse has been playing hide-and-seek with us. It all started when Betelgeuse started to dim back in 2019. Since then, it likes to dim and brighten sporadically. But these changes in brightness tell us about something important. As we mentioned, Betelgeuse was always a bit of a troublemaker. It's been living a fast and furious life. Because of that, it has been burning its fuel at an incredibly fast rate. The changes in the star's brightness are clues that Betelgeuse is approaching the end of its life cycle. The drama intensified when the Hubble Space Telescope snapped jaw-dropping images of Betelgeuse, like it was getting ready to blow its top. All this made scientists think that the star is close to retiring in a dramatic way. It's about to go supernova. So picture a star partying hard, powered by the fusion of hydrogen atoms. It's like the star's own energy drink, but just like any party, the fuel starts to run out. That's when things get interesting. As the star guzzles up its hydrogen fuel, it slowly begins to run on empty. It can't sustain itself anymore. So now, it's time for the grand finale. This finale is called supernova. The star collapses in on itself like a deflating balloon. The pressure and temperature inside skyrocket to mind-boggling levels, and this celestial tantrum triggers a colossal bang. So you can see why observing Betelgeuse is like having a front-row seat to the spectacular drama. But here's the big question. When will this happen? Well, the answer is not as simple as setting a timer. You see, stars have their own schedules, and Betelgeuse is no different. It could be tomorrow, or it could be thousands of years from now. Scientists have come up with only a rough estimate. They believe that Betelgeuse will go supernova within the next 100,000 years. Quite a spread, huh? Sure, that sounds like forever to us, tiny humans. But in the vastness of the universe, it's just a blink of an eye. But there's a chance, just a tiny chance, that Betelgeuse could surprise us all and go supernova much sooner. Considering its dips in brightness, we might be in for a show within the next few hundred years. We'll just have to wait and see. Now, if Betelgeuse does go kaboom, what will happen? Well, get ready for a show like no other, folks. When a star collapses under its own weight, it unleashes a cosmic firework of epic proportions. The star releases a crazy amount of energy in the form of light and heat. Betelgeuse's supernova is going to be extra special. It's like the superstar of supernovas. It will shine so brightly that it might even outshine the other stars in the sky. Picture that, Betelgeuse stealing the spotlight. The show could be so bright that you won't need a telescope to catch a glimpse. Nope, you'll be able to see it with a naked eye. It might even be visible during the day, making the sky look like it's hosting the coolest rave ever. After that, the supernova will keep us entertained for weeks. It will be like having a second moon in the sky, shining as bright as the full thing. Imagine that, 2 moons dancing together in the night. After several weeks of lighting up the night sky, Betelgeuse's supernova will slowly fade away, but it would leave behind a souvenir, an ethereal remnant. It's like a fading memory of the star's epic performance. This remnant, too, would slowly fade away over the course of several months. But it's not just about the light show. The boom will send out powerful shockwaves, and we might actually feel them right here on Earth. It's like the universe giving us a gentle tap on the shoulder, saying, hey, look at this amazing spectacle. How dangerous will it be for us? Well, we know that Betelgeuse's supernova would send dust and gas shooting into the atmosphere. It's like a big space sneeze. And this sneeze could cause a decrease in global temperatures. We're talking serious climate impact here. It could even lead to a mini ice age. But these are just assumptions. We don't know for sure if the consequences will really be that serious. But, of course, we want to be prepared for this event just in case. That's why scientists are studying Betelgeuse closely. But, in addition to serious scientific research, astronomers also have a blast of celestial comedy. Jokes are flying left and right. Someone has even created a Betelgeuse status account, which you can check yourself. So, as you can see, the star is keeping us on our toes. Astronomers keep observing it, and they need our help too. They want us to keep an eye on Betelgeuse and report any changes we see. How do you do that? First off, channel your inner astronomer and observe Betelgeuse. Take a peek at the star and note down what you see. Is it twinkling, shining, or feeling a bit dim? Jot it all down. Then be a superstar yourself and report your observations to the astronomers. Your observations will help them track Betelgeuse's journey towards its big supernova moment. You can also join in on some citizen science projects. They're super fun and easy, trust me. One cool project you can jump into is the Betelgeuse Brightness Monitor. By participating, you help scientists keep tabs on how bright Betelgeuse is shining. Your contribution can make a real difference. So join the monitoring team. You'll be part of something amazing, and who knows, your observations might even help predict when Betelgeuse will show off its supernova magic. By doing that, we can assist them in monitoring this superstar and learn more about the fascinating world of stars. But that's how we can help scientists to predict this event. Now, how can you personally prepare for it? First things first, you'll need the right gear to catch all the supernova action. A trusty telescope is like your front row ticket to the starry show. It'll bring you up close and personal with Betelgeuse's performance. And remember, you'll need special eyewear to shield your eyes from the intense burst of light. Safety first. And of course, prepare in case it decides to mess with our climate. Stock up on essentials, like warm clothes and supplies, just in case we experience a mini ice age. But let's just hope it won't happen. So keep your eyes on the night sky, my friends. Betelgeuse may not be ready to blow up just yet, but when it does, it will be a sight to behold. Until then, let's enjoy the twinkling stars. And remember, there's always something extraordinary happening in the vastness of space.